similar to the very last problem that we considered. All right. So a 1 kilogram arrow is fired into and sticks in a 10 kilogram wooden block on a surface where the coefficient of kinetic friction is 0.4. The arrow and block move 10 meters after the arrow strikes it. What is the initial velocity of the arrow? All right. So this involves several different ideas. Right. Basically, we need to consider the act of friction, and we also need to consider the conservation of linear momentum. Let's start with the friction first. Right. So let's draw a picture. We have an arrow. It's the mass of the arrow is equal to 1 kilogram. We have a velocity of this arrow, which is something we don't know. We have a block, which is sitting on the friction full surface, whose mass is equal to 10 kilograms, and the velocity initially is 0. Right? Now, the final state is going to be a block which is moving with some velocity, right? Which is something we also don't know, right? Of the arrow and the block. So this entire mass here is going to be 1 kilogram from the arrow plus 10 kilograms from the block is equal to 11 kilograms. And it's going to slide along the surface for about 10 meters. Okay. So let's start by considering, we need to do several things. First, we need to be able to compute what the velocity is, all right, of the block plus arrow system. And then from that, we can use the conservation of linear momentum to get what the velocity of the initial arrow was. So let's break this part into two. Okay, so let's get the initial velocity. Let's get the final velocity of the block first. So final velocity of block. Okay, so what do I know? I know that the force of friction is equal to basically the coefficient of kinetic friction, mu sub k, times the normal force. And the normal force in this case is mu sub k times, if you draw a free body diagram here, it's just going to be the mass of the arrow plus block times g. Right? Okay, so let's compute this thing out. The coefficient of kinetic friction is 0.4. The mass of the arrow block is 11. And g is 9.8 meters per second square. Right? So you just put all these things together, it just turns out to be something like 43.12 newtons. Okay, so the next thing we need to do is we need to figure out basically what the initial velocity would be given the final velocity, right? Okay, so to do that, there are two ways to do that. One is we can use an energy argument, but the other way of doing that is to note that we have this formula right here. Vf squared plus Vi squared is equal to 2As, all right? You recall this from basically our discussion in terms of velocity, acceleration, and distance, where s is the distance, a the acceleration, Vi is the initial velocity, and Vf is the final velocity. Okay, so in this particular case, the initial velocity is something we would like to know. The final velocity is the final velocity of the block, which is going to be 0 exactly. All right. Okay, so what we have is going to be, we're going to have Vf squared plus Vi squared is equal to 2As, right? So Vf is going to be 0 squared. Vi is something we're trying to figure out. This is going to be equal to 2As. What's acceleration? So it's important to know here that it's going to be 2. The acceleration is just going to be the force divided by the mass, right, times the distance, which is 10 meters. Okay. In this case, we know what the force is. The force is 43.12 newtons, and the mass is going to be 11 kilograms, right? So this ends up being 2 times 43.12 over 11 times 10 meters, okay, is equal to Vi squared, okay? Now, if you compute this thing out, right, you will find that this number here, just plugging in your calculator, is about 78.4. All right. Okay. And so if you take the square root of this entire thing, VI is equal to, oh, I should write a little more clear. So this is equal to 78.4. And let's take the square root of that. So VI is just going to be equal to, in this case, if you write it out, it's going to be 8.85 meters per second. All right, that's awesome. Okay, so now we know that this is equal to 8.85 meters per second. And now we can use the conservation of linear momentum to get the rest of it. Right? So to recap, the linear momentum is going to be basically initial momentum is equal to the final momentum okay, and so this is going to be the mass of the arrow m sub a, okay, the velocity arrow v sub a, plus the mass of the block m sub b, the velocity of the v sub b, and this is going to be equal to the final momentum, which is the mass of the arrow and block mab times v of the arrow and block VAB, which happens to be 8.85 meters per second. Okay, so if we were to just write this down, the mass of block and the arrow is 11 kilograms. This is going to be 8.85. And this is going to be the mass of the block initially is going to be 10 kilograms. But fortunately, we don't really need to worry about that because the velocity of the block initially is 0. And this is going to be equal to 1 kilogram of the arrow times the velocity arrow, which is something we want to find out. Okay, so if you plug this all together, you can find that VA is equal to 11 times 8.85, which happens to be 97.3